Hello everyone. In part 2 of this video I made it possible for my character to attack by adding projectiles to the game. Although the ability to fire projectiles is kind of pointless without enemies to shoot at, so that's what I'll be adding in this video. After working with the player object and adding projectiles, adding an enemy is pretty straightforward. All the code needed to create an enemy already exists between the player object and the projectile object, so most of the enemy code is just copy and paste. The first step is creating a new sprite object by copying most of the player's starting variables, and then adding an image of what I want my enemy to be. Since the only goal here is to create a working enemy, I decided to go with something simple and chose the Goomba sprite from Super Mario Bros. 1. The Goomba sprite only has 2 frames of animation, so it will be very easy to animate. When I add the newly created sprite object to the game, it looks like this. So far the sprite only has an image and starting coordinates, and it doesn't do much. It hangs in the air instead of falling because it doesn't have the collision codes yet, which would cause it to fall onto the platforms. It also doesn't appear to be walking since I haven't added the animation code yet. If I add the collision code, the Goomba will appear to fall on the platforms, but it doesn't land quite as expected. This is because the sprite's image doesn't determine how it interacts with the map. Where the object touches the platforms is determined by an internal sprite object that's used to represent its detectable area. In this example, I've made the detectable area visible so it can be adjusted. Since it was copied from the player object, it's currently sized to the size and position of the player and not the enemy. If I position the detectable area sprite over the image of the Goomba, it will now land on the platforms where it's supposed to, and the Goomba sprite will now look as it should on the map. The Goomba sprite can be moved easily simply by assigning a value to its x velocity, but it won't appear to be walking since I haven't added the animation code yet. The Goomba sprite only requires 2 frames of animation, so it didn't take long to add the animation code that makes a Goomba appear to be walking. Now that the Goomba can interact with the platforms and move around the map, it needs to be able to interact with the player. It should be destroyed if the player shoots it. This can be done by adding the projectile sprite group into its collision code. If any collision is detected in the projectile sprite group, the sprite will be removed from the screen. Removing the sprite from the screen is enough to show the enemy has been destroyed, but in most games the destruction of enemies is usually animated, so I use the frame of the squished Goomba from the Mario Bros. Sprite sheet. It isn't really the best looking animation, but it could probably work for a simple example. But I decided it would be better if the Goomba just exploded. You can't have too many explosions in a 2D platformer, so it seemed like a good idea. It may not have been necessary for the example, but the sprite mapping utility I made makes it pretty fast and easy to add animation loops, so it was worth a try. In the end, it does make destroying a Goomba a little more interesting. At this point, I thought it would be a good idea to try adding a second enemy to the map. Adding another explosion could certainly only stand to benefit the game, so it's clearly a useful test. It turned out to be more useful than I was expecting because it exposed a definite flaw in my code. Adding a second enemy slowed down the game significantly, which is quite a problem. This is just an example level, but a real level would have many enemies on the map, and if my code slows down after adding just 2 enemies, then it will never be able to run a real map. I needed to take a look back at my code and see if I could find out what was causing it to slow down. At first I suspected the animation engine I built because it was the one part of the code that was fully created by me. It's very possible that I may have made a mistake and used more resources than necessary to get the job done. When I looked back at my code, I realized the animation engine was a little inefficient, but after cleaning up the code it didn't add much speed back into the game, which means the animation code wasn't actually the problem. This led me to investigate my other suspect, which was the collision code. As I understand it, the collision code works by testing the player object's detectable area against every platform on the map. That might sound like a surefire way to make sure the player always collides with all the platforms, which it is, but it also uses a lot of processing power checking for improbable collisions. If Mega Man is in the upper left-hand corner of the map, there's pretty much no way he will ever collide with a platform in the lower right-hand corner of the map on the next update. So there's no need to test for a collision there. There's also no need to test for a collision with any of the platforms that aren't on the screen. In fact, it's not even necessary to test for collisions with some of the platforms that are on the screen because Mega Man can only move at a maximum velocity of 8 pixels. So really the only platforms he could possibly collide with are the ones within 8 pixels of his current position. Thinking of it that way, it's pretty clear that the collision function is definitely using resources testing for improbable collisions, but the only way to find out whether this would cause a problem is to test it in the game. I noticed that keeping the animation engine running, but disabling the collision function did bring the game back up to its usual frame rate, which means the collision code was causing the game to slow down. At this point, I could have upgraded the player's collision function and then copy it to the enemies, but instead I decided just to move the enemies without using any platform collisions at all. I did this by putting the enemies on a track, so to speak. They'll move on a predefined course, so no collision detection with the platforms is necessary. There's no reason to ever test where the object is on a set course because its path and position are already known. Using this approach, I can make the Goombas avoid falling off the first platform by reversing their x velocity when they reach a specific x coordinate, which in this case is the end of the platform. With the Goombas avoiding any collision detection with the platforms, the game can now have multiple enemies without experiencing slowdowns. Although I did want to know how many of these enemies I could have before it did slow down again, so I added 10 more Goombas. The game did slow down, but it was still playable. Adding enemies to the map that don't even appear on the screen isn't really the best approach to adding multiple enemies anyway, so I just did this to test performance. In this example, it's kind of hard to see all the enemies that have been added to the map, so just for fun I updated the camera a little bit so it can be changed to follow projectiles instead of the player. This way I can fire a shot and quickly see all the enemies that have been added to the map. Now that the enemies can be destroyed by the player, they also need to damage the player. Otherwise, they aren't as much enemies as they are just target practice. Although this will involve updating the player object, not the enemies. The player can be damaged by the enemies by adding the enemy sprite group to the player's collision code. Having the player detect a collision with any enemy in the enemy sprite group is easy, but animating it is not because my character doesn't have animation frames for taking damage, so I have to use the sprite mapper to add the missing frames. When the frames are added, it can be seen when Mega Man encounters an enemy and is taking damage, although this isn't much like what you would expect to see in a game. Typically, a character will be thrown back a little bit when colliding with an enemy, so the player doesn't just stand there continuously taking damage. I can accomplish this by creating a taking damage animation loop that will also manipulate the player by disabling the keyboard input and changing the player's velocity for a few moments. This way the arrow keys can't move the player while it's taking damage, and its velocity will be locked for a few moments as the player is pushed away from the enemy. It's easy to decide which direction to push the player sprite when the player runs into an enemy, but when the enemy runs into the player it's a different story. To detect collisions with enemies, I borrowed pieces of the collision codes used for the platforms. The platform's collision code determines which side of the player the collision happened based on the direction the player is moving. This makes sense for platforms because the platforms don't move. If any collision happens with a platform when the character is moving left, the collision could have only happened on the left side. The platform collision code didn't have any means of detecting a collision when the player was standing still, because none of the platforms would ever run into the player. The basic collision function that Pygame uses tells you there has been a collision with two objects, but it doesn't return any immediate information about which side of the objects have collided. It does, however, return the objects themselves, so by looking at the objects that are returned, I can find out where the collision took place. To detect which side of the player has collided with an enemy, I compare the right side of the player object to the left side of the enemy object. If there is less than a 10 pixel difference between these two sides, the collision took place on the right side. If there's more than a 10 pixel difference, the collision took place on the other side. One last thing that was needed to complete the taking damage animation loop was a new variable I just called right momentum, which tells the animation engine which way to push the player based on the collision. I couldn't just use the already existing face right variable, which describes which direction the player is facing, because the player may not always be facing the enemy when it takes damage. Now that I have animated enemies that can move around a map, be destroyed, and damage the player, adding enemies to the game is complete. My game now has all the core mechanics of a basic 2D platformer. So now I can get Mega Man off this example map and onto a real map that has enemies, obstacles, and objectives. But I'll cover that in the next video. Thanks for watching this video. I hope you tune in for part 4.